In contact with a platinum catalyst, an unknown alkene reacts with 3 equivalents of hydrogen gas to give 1 isopropyl 4-methyl cyclohexane. When the unknown alkene is ozonized and reduced, the products are the following. Deduce the structure of the unknown alkene. So let's go ahead and look at the first sentence here. It says that we have an unknown alkene. Alkene means I have a double bond, and it reacts with 3 equivalents of hydrogen gas to give 1 isopropyl 3-methyl cyclohexane. So I'm reacting with 3 equivalents of hydrogen gas with the platinum catalyst, and I'm going to get cyclohexane, which is a 6-carbon ring. And if I number it, you can number it any way you want. I'm numbering it this way. 1 has an isopropyl group and 4 has a methyl group. Now, what does 3H2PT mean? H2PT turns double bond into a single bond. The fact that we need 3 means that there used to be 3 double bonds. So the original reactant looks something like this with 3 double bonds. We're just not sure where these double bonds are. And this is where the second part of the question will come in. So here we are told that when we do ozonolysis, we're going to get these products. And just to remind you, ozonolysis is when I have a double bond. Let's say this is my double bond, and my reagent is O3, and ozonolysis under reductive conditions with reductive workup, a red workup. Basically, I cut my double bond in half, like this, and I end up with an oxygen on the end of each half. This is my product. So it makes sense that we see a lot of oxygens here. Now, how can we go from these structures back to the reactant? Well, what I usually do is I align the double bond O's next to each other to know where the double bond used to be. So if we align these 2 double bond O's with one another, then we know the double bond used to be here. So here I see that I have 1, 2, 3. I have a double bond O on carbon 1 and on carbon 3. And if I check here, I also can see 1, 2, 3. So I probably should align these 2 together because they have 1 carbon, both of them have 1 carbon in between them. They probably went together. So let's go ahead and align them. And then this one can be aligned with that. So let's go ahead and do that and see what we will get. I have 1, 2, let's say 4 and 5 here. 1, 2, 3, 4, and 5 carbons here. And we said carbon number 4 is probably with this one. So I'm going to align it with this carbon. This is a methyl group. And then I have to align this, and I'm going to align it with this molecule. I could either align this carbon with carbon number 1 or this carbon with carbon number 1. So we will align and we will see what the product is. I can see that this is a methyl group. I need to get isopropyl, so we will see if it will match what I have written here or not. So let's go ahead. For some reason I have a feeling that let's align. Okay, let's begin by aligning this carbon with this carbon. So we will say CH3 carbon double bond O, CH2 carbon double bond O H. Okay, everything is lined up. So this is where my double bonds would be. You can see that this is a ring, and I'm going to go ahead and I'm going to number it again. Hopefully it will work out. If not, I will have to rotate the second molecule. So let's go ahead and say 1, 2, 3, 4, 5, 6, and draw a 6-member ring. 1, 2, 3, 4, 5, and 6. One has a methyl group, 2 nothing. Between 3 and 4, I have a double bond. Between 6 and 1, this was 1, I have a double bond. My carbon number 4 is connected to a carbon that has a methyl group, and so a carbon that has a methyl group, and also this carbon that has a double bond, so another carbon. And I think that's my product. Now let's check, does it look like this structure? So have a cyclohexane, I have a methyl group here, and I have an isopropyl group here. So this indeed corresponds to my structure. I don't have to switch anything around, and I figured out where my double bonds were. My double bond was here, and the third double bond was here. This is Mayya from Transformation Tutoring. Please subscribe and like to see more of my chemistry videos.